Welcome to the tutorial on how to import a new wing from XFLR5 to Solidworks without editing any features in Solidworks. In this tutorial, I will show you how to take an existing aircraft from XFLR5, export the airfoil into Excel, and convert into a text file that Solidworks used to build a point-driven curve, which we will use to construct the wing. First, I will show you how the concept works in Solidworks. Right here, we have a pre-existing wing in a model I call wing template. First, the model is driven by two curves, the wing wood and the wing tip airfoil, as you can see here. So the model that I created, you can change the wing wood and wing tip by inputting a text file like this, and that's going to reconstruct the entire wing. Likewise for the wing tip, I can change the wingtip entirely, and all the features will rebuild. This model is made specifically for wing construction using foam and wood. There is one major spar inside the aircraft and two whips. Everything else will be made out of foam. So, how do you import a new wing into this? Let's start from XFLR5. Right here you're seeing a flying wing, and right here you're seeing a conventional wing. In this tutorial we assume that you already know how to use XFLR5 and familiar with airfoil, so we're not going to get into the analysis in XFLR5. Instead, we will start from an already working model that can lift 2 pounds at 30 miles per hour. First, click on Plane, Current Plane, Edit Wing. Right now you'll see two sections of the wing, Section 1 and Section 2, corresponding to the wing wood and the wing tip. Chord length, which is the length of your airfoil of that section of the wing. Offset, which is the position of your wing in the Y direction. In the X direction. Dihedral, how your wing is angled up and down. And twist, which you can use to make a wing that twists at the end. So we will keep this window open and open up the Excel file. Let's call XFLR5 to Solidworks Wing Importer. In this file, you will see 4 sheets. There's input for the wing wood, input for the wing tip, and output for the wing wood and output for the wing tip. First, you will need the DAT files. In order to get that, you need to go to Files, Direct File Analysis, and then select the airfoil that used on that wing. In this case, is the Nacker 65013. Right-click, Export, and this will be the proper name for the file. Since the airfoil on both wings are the same, we're only going to export one. And we'll go back to File, Wing and Plane Design. You can click Ctrl W as a shortcut to go to the wing. As you can see, the file is Nacker 65013 on both. And now you have this file. Right click. The file will be a DAT format. Right click. Open with Excel, and you should see 2 columns with 92 points. So you would copy the first column up until the last row, or you can click on Ctrl A, copy, and paste it on the other Excel file. Delete the name of the airfoil. Now, after you have the data, click on Text to Columns. Use delimited. Next. Uncheck tab. Check space. Next. Do not import column. Skip. And then finish. There's already data here. Do you want to replace it? Yes. And now you will have output. And because we do not have any data past 93, you want to delete those. And then right here, you import the wing width parameter from XFLR5. In this case, y is 0. Offset is -2. Chord is 8. Dihedral will be input into Solidworks directly. We have 0° twist, and the angle of attack of the wing is 0. The angle of attack of the wing corresponds to this number, which is -1 instead of 0. To get to this, you would click on Plane, Current Plane, and Edit. And you can see the tilt angle. The output automatically updates using the equation that takes your chord length, offset, twist, and angle of attack of your wing, and multiply into the output. And now click on Select All or Control A. This will select everything on the output. Control C to go to wing width output. Click on first column, first row, first column. Control V to paste, and then paste values only. This is important, otherwise your equation will be broken. And then make sure you save your file at this point. And then click on Control F. Alt F, and then Save As. Save it as a text file, text delimited. This is very important because if you have any other file, Solidworks would not recognize it, would not be able to open it. And name this the conventional wing width, and save. Click OK. Close the Excel file. Click No. Open Solidworks. The two things you need to edit is the wing width airfoil and the wing tip airfoil. First, we just made the wing width airfoil, so you'll click on Edit Feature. Browse. You have to change the curve file type to text file, otherwise you will not see you will not be able to select the file. Click on Conventional Wing Width. So when it gives you this error, that will mean your point does not match the number of points in your airfoil model. So go back to the Excel file. Go back to wing width output, delete all the numbers. Go back to wing width, copy the new number with only 93 volts. Paste it again as values and export it again to the file we just had. Close Excel and browse to the file again. Now, this is our new airfoil. As you can see, the whip, spar, and wing geometry automatically updated to the new file without editing any feature whatsoever. Now let's do the wingtip. We no longer need the airfoil, so you can close that one. Open up the Excel file again for importer. Go to wingtip. Copy all of these airfoil input, paste it onto. First delete all of this and paste it again. Delete anything else that you don't need. And then modify the data according to Solidworks. Y does not need to be inputted. That will be a wingspan that is adjusted on Solidworks. Chord length is 5. Offset is -2. Twist is 0. And wing angle of attack is the same as the wing would, -1. Now copy all the output and put it on the wing tip output. Again, delete all the old data. Place this value only. Save. And then save as. Again, text tab delimited. And this time name it conventional wing tip. Okay. Close Excel and click No. Go back to Solidworks. This time edit the feature for wing tip. Browse. Text file. Change file type. Conventional wing tip. And OK. Now as you can see, the wing has been completely updated to the new airfoil. But now, how do you adjust dihedral and wingspan? A dihedral and wingspan is 15 inch on each wing. To do that, you go to wingspan, edit feature, and change this number to match what is in XFLR5. Currently it's 15, which is correct, so we'll leave it as it is. Dihedral angle, same idea. Edit, change it to 3 degrees. That's what we have on XFLR5. Click OK. And now you have a wing that is exactly as designed in XFLR5. There's a cutout for the fuselage that you can edit the sketch in order to change the size, which is right here. To edit that, you go to Wing, Top Sketch, and change this number right here. This determines how wide your fuselage is. So if you have a 3-inch wide fuselage, you will do this as 1.5. And that will automatically narrow down the gap between the wings. So that is one example on how you update your wing geometry without having to edit any feature in Solidworks. Now, you can also use Solidworks. You can also use Solidworks to create a file that you can cut in the laser cutter. Using the surface flattening command, this unfolds your airfoil into a sheet that you can directly take into a laser cutter. This also automatically updates according to your airfoil. To show you another example, we also have the flying wing model in XFLR5. It's designed to generate the same lift with a different wingspan, airfoil, and dihedral angle. In this wing, we are using the Nacker 33012 and Nacker 0009 airfoil. So first you will go there, direct foil design, find those two airfoil, and export them to DAT files. Now go back to wing and plane design. And make sure we're clicking on the fine wing. Tilt angle is 7 degrees. So you will go into the importer. Wing width, change this number to 7 and 7. Click on define wing. Update this number accordingly. 12 for wing width. Offset -10. Dihedral 5, we do not input it in Excel. Twist of -5. And again for the wingtip. 8 chord, offset 15, twist -12, and then now open the airfoil data. The Nacker 0009 is the wingtip, so we go to wingtip and place the values. Select all the data that you just imported. Click data, text the column, delimit it, next. Uncheck tab, check space, next. Do not import column, skip, finish. OK. Now, because previously we only have 93 volts, now you need to make sure you have everything all the way up to the number of data points from the imported file. Ctrl A, Ctrl C to copy the data. Ctrl V, place values only. Save the file. File save. Control save and file save as, browse, and this time name it fine wingtip. OK. Close both Excel files. Open Solidworks. Edit the wingtip airfoil. Change file type to text. Fine wingtip. Click OK. As you can see, the wing tip has been updated, but some of the dimensions are not correct. So you have a 40-inch wingspan on each wing. So you will update the wingspan parameter to 40. Just like that. And your dihedral angle is 5. So change the dihedral angle to 5 degrees. OK. Now let's go to the wing wood. The wing wood airfoil is the Knacker 33012. So open that. Copy all the data to wing wood. Delete first row. Text the column. Delimit it. Space. Do not import first column. Finish. And copy all of this. And make sure it fills every single column. Copy your output to the wing wood output as values only. Save your data. Save as. Text delimited. This time is define wing wood. .txt. OK. No. And close out all Excel files. Go back to Solidworks. Wing tip airfoil. Wing wood airfoil. Browse. Find wing wood. OK. And now you have the new flying wing. That concludes our tutorial on how to go from XFLR5 model to Solidworks without changing any features in Solidworks. And this will be the end of our tutorial. Have a nice day. Goodbye.